Okay, so we're starting another video, just where we left off on the last one. At this point, I have solved for this series resistive capacitive circuit. If you want to know how I got some of these numbers, you'll have to watch the earlier video. Hopefully you did. Hopefully you're starting this one right afterwards. I've solved my angle theta. I've taken my my power at the, I shouldn't have erased those. I've taken my watts and divided them by my apparent power, and I've gotten a power factor of 0.8615 or 86.15%. Angle theta on that is 30.52. That angle theta, again, is this angle here. If this is my power apparent, my hypotenuse, and this is my power true, adjacent over hypotenuse for this angle is cosine, and my invert cosine of this number of that relationship gives me that angle theta. And that angle theta, when I dumped it in my calculator, in the old school days, if you watch that other video, that guy had a whole table. He didn't have a calculator you could dump an angle into or dump a relationship into and get an angle for cosine. He actually had to go to a table. But we actually have calculators now that do all that for us. So the angle that I came up with was 30.52. And so that is not only that angle on all of my triangles that I've written for this circuit, but it's also the angle between the two sine waves. So if I have one sine wave there, and I don't even know if that's current or voltage yet, we'll talk about that in a second, and I have another sine wave that's 30.52 degrees different. Well, if this is 90, it's about a third of the way through there, right? So here would be about well, this is maybe a third of 90. And I just kind of follow it. Not easy to do, and I'm not grading on art on this, and obviously this would continue to go, and so would that, but it's tough to do that sometimes. This is what my angles look like, and I'm going to say that between these 2 points, I've gotten, I'm even going to label it so that my instructor knows what I'm talking about, 30.52 degrees between those 2 angles. So I could start figuring out my 90 on either one. But either way, this is a third of the way roughly to 90 degrees. It's 30.52. Now, I've got one of those angles, one of those sine waves is my voltage sine wave, and one of those sine waves is my current sine wave. Well, which one is which? Well, remember, I've got that mnemonic. Eli, the Iceman. This is a capacitive circuit. That's my timer telling me the last video's time is up. So this is a capacitive circuit. Stop. This is a capacitive circuit, so I'm going to use C. Eli the Iceman, C for capacitive. And that tells me that current is before voltage. Current leads voltage, or voltage lags current. So this sine wave happens before this sine wave, right? Because it's crossing zero here. This is now, and this is a little while from now. So this first one is going to be current, and this second one is going to be voltage. I need you guys to label those for me because it's important to know the relationship between which, whether it's current that's first or voltage that's first. Now, I've been giving you one sine wave. I've been drawing the first sine wave and letting you put the second wave in. You are welcome, and I'm going to stop labeling that first sine wave. So you can draw your second sine wave any way you want to, but I want you to label the 2 sine waves that are done. Maybe I should let you draw them both. Yeah, let's do that. I'll let you draw them both. I need you to label and tell me which is voltage and which is current. And it should reflect this, Eli the Iceman. Draw that in there. You'll have voltage, you'll have current, and we'll be good. Now, this is the material that I'm going to cover in this week's quiz. However, next week we're going to go into adding capacitors and inductors in the same circuit. So I'm going to put up a video right now. I'm going to make the video as soon as I'm done with this one, showing you what to do on those. And I would like you guys to watch that because there are some subtleties that happen, and I'd like you to have this week and next week to think about that because that will be in the quiz the week following. How to deal with inductance and capacitance in the same circuit. What I'm not going to do, but what I want to go over a little bit, in a live class, I'm going to erase all this, I hope it's correct. In a live class, I go over what happens when I've got more than one inductor or capacitor in a circuit. And I just haven't felt like I've had enough time or resource to do that with this online class because of the coronavirus. But I handed out, there were 2 download sheets that you guys should have downloaded, one for capacitors and one for inductors that talked about this a little bit. And here's what I want you to know. If I've got a circuit that's got inductors in parallel, and I know what their capacitance is, I know what their inductance is, I know what L equals. L on this one, let's say that L equals 50 millihenries. And let's say that this one, L equals also 50 millihenries. Well, I know that those 2 things, just like resistors, reciprocate. So if I've got 50 millihenries and 50 millihenries, I've got 2 of them. I know that 1 over 50 plus 1 over 50 inverted equals 25. And I know that because it also follows the cheat rule, which is equal values reciprocating, divide by the number of them. But my brute force method for reciprocating always works. So inductors add the same as resistors. If I have 2 resistors in parallel, however you want to draw them, those 2 things reciprocate. If I've got 50 ohms and 50 ohms, they reciprocate to one 25 ohm resistor. If I have 2 inductors in parallel, they reciprocate the same. And here's another cool thing. Not only do they reciprocate if I'm worried about the inductance, but they will reciprocate with the resistance too. Let's prove that. What did we come up with? We came up with 25 millihenries, right? Let's say there's still 50 millihenries, but let's go ahead and solve. Let's see, x sub L equals 2 pi fly, right? 2 pi FL. So if I dump 2 times pi times 60, because we're electricians, we're doing them in 60 hertz, times 0.050, because 0.050 is the same as 50 millihenries, right? Henries, let's see what that comes up with. This is for 150 millihenry inductor. Clear, clear, on, clear again. 2 pi 60 times 0.050 equals 18.85. 18.85 with a little bit of rounding, and that would be ohms, right? So if I've got 18.85 ohms here, and I've got 18.85 ohms here, the same thing, right? Because I do the math the same thing. Those 2 guys should reciprocate. So 1 over 18.85 plus 1 over 18.85 inverted should equal, and I'm going to do the math really quick in my head. Let's see, half of 18 is 9, because I know that's the same as half of these, right? I could do the math with all of this, but I don't feel like doing it. Half of 18 is 9. Half of 85 is 42 and a half. So it's going to be 9.425 ohms if I solve it that way, right? Let's go ahead and do the 2 pi fly for 25 millihenries. So because I solved, first of all, reciprocated these and said, hey, 25 millihenries, put them together. These ones, 18.85, reciprocate those, 9.425 ohms. So if I use 25 millihenries instead of 50 up here, I'm going to insert 0.025. Let's see what I get. Hopefully I get something close to 9.425, because that's what I'm trying to demonstrate. 2 pi 60 times 0.025. Remember, I'm not inverting that again. I get 9.427. 9.427 ohms. The 7 and the 5 is my rounding error, because it wasn't actually 8.85, it was 85, blah, 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 right? So I rounded that. But you can see it works either way. I can reciprocate these when I solve x sub L, or I can reciprocate them when I'm still in inductance. Either way works. Why do you suppose inductors in series work? Add them up. So I can add 2 inductors in series, I can add their inductance and solve for x sub L, x sub L. I wrote C up here, didn't I? See how easy that is? I did the formula correctly for x sub L, but I wrote x sub C. If I want to solve x sub L for 2 inductors in series, I can just add them. If it's 50 millihenries and 50 millihenries, then that equals one bigger 100 millihenry inductor. If I solve each of these guys, and I think we already did for 18.85 ohms, 18.85 ohms, if I solve for 100 millihenries, I'm probably going to get 37 point whatever that comes out to ohms, because you add them up. Just like resistors, you add them up. Capacitors are the exact opposite. So capacitors, not only is their formula, X sub C is an invert of the formula we know 2 pi F, well, 2 pi fly if we were in L, but now we're in C, 2 pi F C. Not only is the formula invert, but if I have a source and I have two capacitors in parallel they add up. And it actually makes sense if you look at the drawing like this, because remember, what a capacitor is doing is it's storing charge. The charge builds up on these plates. And if these plates are in parallel with each other, and I've got electrons moving this way and this way to build up this charge, how do the electrons know if they're building up on two plates that aren't connected, or really just one bigger plate? It ends up being the same thing. So, capacitors in parallel add. Not only can you add their capacitance, but you can add their resultant X sub C ohms of reactance. When a capacitor is in series, it reciprocates. Rarely are you going to see a circuit with capacitors in series, because they just don't do much for you in series. So they just aren't built that way. But if I have two capacitors in series, and let's say they are 50 microfarads and 50 microfarads, the resultant capacitance is going to be less. It is going to be 20, because there's two of them. They reciprocate. They'll be 25 microfarads. This is all spelled out on those sheets of yours. If you think about what's going on in there, I've got charge building up here, but it can't ever get over here to build up. And when the current goes the other direction, these guys discharge, but this can't really discharge anything, right? So then it starts charging up here. So essentially you've got kind of a break in your capacitance. So it reduces the ability of a capacitor to collect charge and store charge, things the capacitor wants to do. So putting two of them in series, it's like having less of a capacitor. Whereas everything else we've learned, inductors and resistors, you put two in series, you've got more of it. In a capacitor, it's the exact opposite. It's bass-ackward, as the technicians say, in every way from inductors and from resistors. Okay, I'm going to kill this video now. Read your Moodle, do your stuff, watch the next video because it's interesting, and you'll need it for next week. For this week, you don't need it. You need what you've learned up till here. The videos that I posted, really, really highly recommend that you watch them, especially the one from the guy from the 1960s Air Force. It's kind of funny to watch anyways. And also, your reading is going to be really important. I will post a quiz. It is Monday as I make this. I will post a quiz tonight for you guys. Please, 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 I need those on time as PDFs. I'd like you to make them one PDF file for me. Some of you have been submitting PDFs. They're just huge in my browser, and I end up having to open them anyways. As long as it's a PDF, I'll deal with it. But those of you who have sent me JPEGs, I can't do anything with them. I can't even open them in Moodle, and I can't get them out of Moodle to open them up in my regular computer, which seems ridiculous. It is ridiculous. I don't know why, but I need the PDFs. So you should be able to do PDFs. I've been working with everybody on that. Please do. And that's the end of this video.